Hi all! I've been asked to have a look at this question here, which is all about a partial fraction, but with a repeated factor. If you want me to do a question with a not repeated factor, give me a shout and I will do. Right, okay, so it's a repeated factor because we've got a squared term on the bottom. We've got an x squared, which means that we have to have a term over x and then something over x squared as well. If it was this first one that was just an x or an x plus 2 or however, and it didn't have a power on it, we'd only have to put the bracket there once. Okay? Similarly, if that was x on the bottom times x plus 1 all squared, then you'd have to have one lot of x plus 1 on the bottom and another term with an x plus 1 squared. Okay? So that's the sort of thing we're playing with here. Right, so what do we do from here? Well, the trick to this is getting your denominators to be the same. Now, some people say you can use a cover-up method, but that only works if you haven't got a repeated factor. So what we need to do is multiply everything on the top by everything on the bottom so that we can get a common denominator. Right, okay. So if we're going to do that, we're going to have to times that a there by x squared and x plus 1. And we're going to have to times the b term by that x term there and that x plus 1 there. So we've got plus b times x plus 1. And we're going to do the same thing with the c term there. So we're going to have to do c times x and x squared. And now we've done that, we now have everything on that. Let's insert a line there. If I try and draw it freehand, it'll go all over the place. Right, so we've got a line, and then we are going to have now a common denominator of x. Oh, now look, it's not a common denominator. X times x squared times x plus 1. Now that's not common to this denominator here. We've got an extra x term in there that we don't really want. But if we look at the top line, we can take or factorise out a factor of x out of each term here. Okay, now I'm not just going to work my way along crossing things out because that is misleading. So I'm going to take an x out of every term on the top. Okay, so we've got a times x squared. Well, we've taken an x out, so that's just going to be ax times x plus 1. And we've got b times x plus 1. Well, we've taken one of the x's out, so we're just left with b times x plus 1. And we're going to take this c out. So we've taken one of these, we've taken that x, and we're going to take that x. Okay, which leaves us with c times x squared. Okay, and now we've got this factor of x outside. Now we need to do the same thing with the bottom. We're going to take the x outside here, because remember this is commutative. In other words, you can do multiplication in any order and it doesn't change the value of it. Okay, so that leaves us with times x squared and x plus 1 on the bottom. Okay, so that x and that x cancel each other out. Smashing. So we've taken an x out of every single term to factorise it, and then we've cancelled those two x's out. And now our denominators are the same. So now we can move on to the comparing coefficients part. Okay, so comparing coefficients, we've got 1 on this side, and that's just a number. Okay, we've got a 1 here, that's just a number. So if we expand this a term here, we're going to have ax squared plus ax. Well, that's not a number. Bx plus b, that would give us a b. That's just a constant term. And we've got cx squared, so we've got no constant terms there. So straight off, we can say that b is equal to 1. Okay, that's by comparing our constants. I'm going to put c's for constants. Now we're going to compare our x terms. We've got nothing on the left-hand side. But if we expanded this, we'd have ax plus bx. Okay, so a plus b. Well, we know b is 1. So a, therefore, must be minus 1. Okay, and finally, we're going to compare our x squared terms. And that will give us ax squared. Oh, sorry, we've got nothing on the left-hand side. We've got ax squared on this side. Got no bx squared, so forget about b. And we've got cx squareds over here. Okay, so we've got a plus c. Well, A is -1, so C must be equal to 1. Okay, so finally you wrap all this up by saying, right, okay, I mean, it's important that we get the order right here. So 1 over x squared times x plus 1, which was the question at the start, is equal to A, which is -1 over x, plus B, which is 1 over x squared, plus C, going back to here, plus C, which is 1 over x plus 1. And if you really, really wanted to, you could cross multiply all that back out again, and you should find that that is the answer. Oh, and a big shout out to Ali.